We've just derived a differential equation for the radius of a cell that grows in mass by absorbing nutrients and consuming them. And observe that that statement depends on the density and depends on these constants that have to do with absorption and consumption of nutrients. We're now in position to make some predictions of how the cell size will change. Let's first of all consider this whole quantity as a function of the radius, and let's sketch on a graph what that function looks like. However, it's a linear function. It depends linearly on the radius, with this intersection point being 3k1 over k2. Now you may recall that back when we asked under what conditions will absorption and consumption of nutrients match, we found the cell size that is precisely this point. Now when we ask what happens when these do not match, we see that the radius of the cell can change, and now we can analyze how it changes. Now on this graph, we see that the function f of r, which is that rate of change of the radius, is positive throughout this interval and negative over here. So that tells us that any initial radius starting in this range will increase. Its rate of change will be positive. It'll go towards higher radius values. Any initial cell sizes over here, on the other hand, will decrease, leading the cell to approach this radius. So from the diagram, we see that the radius at which the two processes, absorption and consumption, balance is exactly a steady state. We found a steady state at r equals 3k1 over k2. We can see from the diagram that this steady state is stable, and that from all initial radii, the cell will always approach this steady state. To summarize, by writing a balance equation for the cell mass, we see that we obtain a prediction that the cell should always attain its equilibrium state, a steady state, where these two processes do in fact balance.